So this right here, this is your y-intercept. And underneath that, I want you to put 0, comma, c. We'll talk about what all that means here in just a minute. Your vertex is right there. Underneath that, I want you to write negative h, comma, k. Now, we've talked about this and why that is negative. Can somebody remind me, or remind the class, why is there a negative in front of the h right there? And it was last class that we talked about this. Do what, Alberto? It's the okay. Essentially, yeah. The h, that's the left and right opposite the sign. So whenever I have negative h up there, that means if in the equation, if you have x plus 3, and you'll see the form here in a minute, x plus 3 in parentheses squared, it goes to the left. If it's minus, it goes to the right. You also have your roots, which essentially is just the x-intercepts. That's all it is. These are also going to be opposite the sign whenever you look at the form. Okay, and you're going to have 2 of them. Okay. So make sure you know where all of these, the anatomy of the parabola. Okay. Going down to what these forms look like. Alright, you will see this notation where it's s of x, v of x, and then f of x, but a little bit different. It's not that f of x you're used to seeing. It's a capital F. That is telling you what form that is in. So if you look at an equation and you're looking at it and I have no idea what form that is, well, if it says v of x equals, it's telling you that it is the vertex form. F of x is telling you that it is the factored form. Okay, so use that notation to help you out so you know what form you're looking at. Standard form is the form that you have seen the most and you will continue to see the most likely. And it is just that ax squared plus bx plus c. The information, the piece of information you're going to get from that is your y-intercept. And that is the 0, comma, c. Okay, so whatever that number is at the very end of your equation, the one that won't have x on it, that's what your y-intercept is going to be. V of x, your vertex form. Okay, you've got a parentheses x plus h squared plus k. This is the transformation, the form that we looked at last class whenever we talked about transformations. Okay, it's the form that's going to get you to the vertex. So the vertex form and the form that you have the transformations on, those are one and the same. Again, hopefully it's obvious that the vertex form is giving you the vertex, and that is your negative h. Okay. Your factored form, you're going to have x plus r sub 1, okay, that's just subscript, times x plus r subscript 2. Alright, and you've seen this, the subscript 1 and subscript 2, that's just saying the first root, second root. Okay, whenever you actually have an equation right now, that's not going to be there.
The roots are also zeros.
Okay, the roots are zeros, the roots are x-intercepts, the roots are solutions. It's one of those weird things that has 4 different names for the same thing. Make sure you know this. Someone kind of asked me this last class. Know that all these pluses in here can also be minuses. Someone was confused by that. This is just the form, what it will look like. Alright. the factored form, this is going to give you the roots, x-intercepts, solutions, however you want to look at that. And it is going to give you those two roots. Notice that I also have the negatives in front of that. If you notice, everything, no matter the form, if it is in parentheses, it is going to be opposite the sign. If it is outside the parentheses, that information is going to be whatever that is. Okay, the y-intercept and the y value of your vertex. If it's plus 7, it's going to be positive 7. Minus 8, it's going to be negative 8. What is in all three forms looking at these? A. Okay, I've got A in all three forms. Right here. What is that A value going to do?
Determine if it's up or down. Or no compressor.
Okay, both, yes. It's going to determine if it's negative, it reflects. If it's greater than 1, it vertically stretches. If it's between 0 and 1, it vertically compresses. Okay? The A value in one form is going to be the same in all three forms. If it's 2 in one form, it's 2 in all three forms. It's negative 1/4, it's negative 1/4 in all three forms. Okay? So that A value is going to be consistent across those. So let's go to this right here. In your calculator, go ahead and grab that. I want you to go to the y equals screen. I want you to put these into y1, y2, and y3. Whenever you hit y equals, check all the y equals on there. You might get lucky and someone last class may not have cleared it.
Oh, yes.
You're not doing S of x. Your calculator should look like that on the y equals screen. If it is not, raise your hand. Let me know if you're confused on what you need to put in there. If you look up here on mine, because I got all the fancy little effects up here, that's going to just Kevin. Okay, so if you look up here, you can see all three of them being individually graphed. So there's y1, y2, and y3. Okay, and that's kind of the idea. One of really the big idea of today's lesson is you've got these three forms that look completely different from one another, but all three of them give you the exact same problem. Because each form has a different piece of information from it. So that is what you should have noticed about the three graphs. Okay. All equations produced the same parabola. Okay, so looking at all of these, S of x, the standard form. Okay, Ashlyn, what piece of information does the standard form give us? Okay, and so what would the y-intercept be in this form? You need to just look at the equation. See if you can find it just by looking at the equation.
8.
Mm.
Isn't the C?
It is, but is that C value 8 or is it?
Negative 8.
Okay, and what's the x value?
0.
0. Okay. All you have to look at is just that last number in standard form. That's where it's going to cross the y-axis. Okay, next you have the factored form. Jake, what does the factored form give us?
4, 0, and negative 2, 0.
Okay, and what are those called?
Roots.
Roots. Now, whenever you have the factored form, if I have 2 points that are on the same y value, okay, which if they're roots, they're going to be on the x-axis. What other part of this graph can I find if I have those 2 points?
Axis of symmetry.
Axis of symmetry. Where would the axis of symmetry be?
1, 0, 0, 1.
Well, it's where x is 1,
It's in between those.
but it's x, you would write it as x
Yes.
equals 1.
But do we need to find that?
It's going to help you a lot, yes.
Why do you try to get access
So, whenever you have that axis of symmetry, I can also now graph the point that is symmetric to my y-intercept at 2, -8. Okay? And then the vertex form, Garrett Kreitz obviously is going to give us the vertex, but what is the vertex on this problem?
It's 1, -9.
Awesome. Okay. And so you have enough points there that you can graph those. Okay, so again, kind of back to Max's question of, well, why are there 3 different forms? Because each form gives you something different. Alright? If you know how to graph it accurately, if you remember from last class, you can just as easily take that right there in one form and graph it the way we did it last time, where we did the right 1, right 2, right 3, or the table. The only difference is here, guys, we didn't even really do any math. We just knew where to look. That's all it takes if you got all 3 forms. Okay, so go to the back. Let's look at this. I'll keep it where it is up here so you don't have to flip over and keep looking at that problem. On B, it says to verify algebraically that the standard and the factored form are equal to each other, that they're the same. So one way that we've done this is we graphed it in the calculator, and it gave us one parabola. Okay, but this is asking us to do it algebraically. Whenever I do this, I am always going to work towards the standard form. Okay, so that means on this one, I'm going to start with the factored form. And I'll simplify it, and my final answer needs to be the standard form. So I'm just going to rewrite my factored form, x minus 4x plus 2. Okay. Now somebody tell me what I need to do to that in order to get something in standard form. What is that process called? Okay, distribution, and you can do that whether if you do FOIL or if you do the box method. Okay, it does not matter to me, whichever way you're most comfortable with. So if I do FOIL, which is the way you will see me do it, x times x is x squared, x times 2 is 2x, negative 4 times x is negative 4x, negative 4 times 2 is negative 8. I would then combine my 2 middle terms. I've got x squared minus 2x minus 8. Check that up above. It is my standard form. So that is proving algebraically that that form is equal to the factored form. Going over to C. It says the same thing, but now it's saying standard and vertex, which my vertex was this right here. So go ahead and get this written down. So if I'm going to simplify this, somebody tell me how I handled that part of this equation.
Make 2 x's.
Do what?
Make 2 different x's, like x minus 9, x plus, or x minus 1. I don't know what it's called.
Okay, Garrett?
Since it's squared, that means there's like 2
x minus 1, so you do the FOIL process and then you just do
Awesome. Alright, if you weren't following Garrett, and I'm emphasizing this because what most people will try to do whenever they do it incorrectly is they'll distribute the squared, and they'll give me x squared minus 1 squared, which is not correct. Okay? This means you have two x minus 1s. Alright, which is exactly how Garrett explained it. Alright, so you're going to do that. A lot of times you will hear me refer to this as just expanding your exponent. Alright, if it's squared, you would have 2. If it's cubed, you'd have 3. If there were 18 up there, you would write x minus 1 18 times. Alright, we're not going to have that. Yeah, don't calm down. Okay? But if you had that, that's what you would have to do. And then just like Garrett said, you would do FOIL here. Combine your like terms. Do not forget the minus 9 at the end. Okay? A lot of people will forget that. So whenever I FOIL, I end up with this.
So you FOIL for everyone. That's just
If you have this situation where you get a binomial times a binomial, I do FOIL, yes.
no, even what like are there scenarios where you don't do this? Like there's another transfer. Like we only did 2. You know what I mean?
So whenever you do 1 minus 9, that is going to give you the minus 8. Alright, this next part on D where it says find the following critical attributes. If you were following along with me, you wrote them right here. So just rewrite them down here. Your vertex is 1, negative 9. Then you've got your roots and your y-intercept. So you have your y-intercept, your roots, and your vertex. Okay, so looking at this, again, just making sure we are all clear on what piece of information is found in what form. Colton, the standard form gives us what piece of information?
Usually the y.
Okay, y-intercept. Kiera, the factored form gives us what piece of information? The roots. Okay. Kevin, this is a toughie. The vertex form gives us what piece of information?
Vertex.
Attaboy. Proud of you. Okay. So again, just making sure that we are clear on what piece of information goes with what form. So first, you have that factored form. So, Bo, what would my two roots be from there?
0, 6. And then 0,
So negative 6, 0. And then what's the other one? 2, 0. 2, 0. Okay, so I've got those two. Negative 6, 0, 2, 0. Again, my factored form also gives me what piece of information on the graph? The axis of symmetry. Okay, so if that is 8 units across from one root to the other, then I can go in 4 units from either one. And I've got my axis of symmetry right there at x equals negative 2. Sam, what would my vertex be from there? Yes. Yep. Yeah.
Why?
Left 2,
Oh, negative 2.
down 32.
That won't fit on
Correct. Yes, this is a poor graph for this example. We're just going to graph what we can here. Looking at this right here, Connor, what would the y-intercept be? 0, negative 24. And again, this is a poor graph for this problem. But you can tell that it would be some kind of concave up parabola. Alright, what do you notice about all three equations?
0.
No.
They all have the same A.
They all have that 2.
There. Okay. So the A value is 2. So what is that doing to the graph? What is that transformation?
Vertical stretch.
Vertically stretched by 2. Alright, so let's look down here. Same kind of idea as what we did just a minute ago. But we need to make sure that we know how to handle a certain situation on this as well. Oh, that's as far as over there.
Do you distribute that?
So do we not touch the 2?
No, do you, yeah.
No, you have to deal with the 2.
You distribute then foil.
So you've got, let's talk about it. Let's go ahead and write it out. So write your factored form and then let's talk about what Max and Garrett are already kind of asking about. Alright, so you've got factored form. Whenever you distribute, what operation is that? Oh, it's distribution, but am I adding, subtracting, multiplying, or dividing? I'm multiplying. Whenever I do FOIL with these two, it's multiplication. So really I'm multiplying three things together, correct? Okay, so let's kind of step away from this problem for just a second. If I'm multiplying three things together, 2 times 3 is what? 6. 6 times 4 is what? 2 times 4 is what?
8.
8 times 3 is what? 4 times 3 is what? 12 times 2 is what? So if I'm multiplying three things together correctly, does the order in which I do it matter?
No way.
No. I can multiply the first two things, which is just distributing the 2, and then multiply what I get there with the third thing, which would be FOIL. Or I can do FOIL first and then distribute the 2. The one thing you cannot do is distribute this 2 to the x, the 6, the x, and the negative 2. Okay, you wouldn't do 2 times 3 and then 2 times 4. You would do 2 times 3 to get 6, or 2 times that to get 2x plus 12, and then multiply it by the third one. Whenever you see me do this, I'm going to FOIL first. Okay, that's just how I go about these. So I'm going to FOIL the x plus 6, x minus 2, which will give me x squared plus 4x minus 12. And then now I'm going to distribute my 2 to all three terms.
So why don't you also
It's explained like if it's x plus 2
Okay, so here are the rest of the steps of that problem.
Yeah, but after.
So, re-looking at this problem, on a lot of, and there's especially going to be application problems, you'll have some word problem where you'll be given the information to where you can find these things most of the time. Okay? Your x-intercepts and your vertex. And you need to write as much of those forms, max, as possible. Now, you have to assume that the a value is going to be something other than 1. So you're going to have to find that a value, which is what I'm talking about here. So this is kind of a tough parabola to come up with some story with. The one I use first period is there's those birds that dive bomb down into the water to get fish and then fly back out.
Seagulls?
Sure. We'll call them seagulls. Okay? So let's say they're doing that. So this is the path of that bird going below the surface of the water and then coming back up, reach the depth of 32 feet, let's say, whatever. Okay? The easier examples of this, so we'll use this. A lot of better examples are concave down parabolas. The path of a baseball after it's hit, a rocket getting shot up, and then somewhere gravity takes effect, and it kind of has that parabolic path. So there's plenty of examples. But you'll have this, and you'll have to find this a value. So what you can do to find that is you can plug one of your x-intercepts into your vertex form or your vertex into your factored form. Whenever I do this, I will find the root that has the smallest number. 2 is smaller than 6. I know it's -6, but 2 is that's going to give me easier calculations than -6. And I'm going to plug that point into the vertex form. Okay, so the y value of that point is 0 equals, I'm writing a because I don't know what a is yet, parentheses, and then I'm plugging in 2 plus 2 squared, what is it, minus 32. And then I'm going to solve for a. Okay, what is 2 plus 2? 4. What is 4 squared? 16. Okay, what would I need to do next to solve for a?
Divide. You put on the
Not
other
yet.
side, and divide.
Need to add 32. And then 32 divided by 16 is what? 2. So now I can go back to my 3 forms, erase where I have written a, and write in 2. Okay? And then usually I will simplify the factored form. Okay, so I would do FOIL here. And then once I do FOIL, I would distribute my 2 to the 3 terms. And that's going to give me the standard form. Okay, that is exactly what we did right here. Okay, it's that process to get to that standard form.